Okay, so this is the third part of our rational videos. So today we're going to talk about rational graphing. And so taking all that information that we've talked about in the past, on the last two videos, taking all of that information and putting it into a graph. And let's really decide what does that look like, if it's a horizontal asymptote or if it's a vertical asymptote. What does that actually look like? So here we go. Alright, so using the four examples that we talked about on the last video, where you guys had to identify x-intercept, y-intercept, horizontal asymptote, vertical asymptote, and if there was a removable discontinuity. So building off of what we already have, that's what we're going to talk about today. So starting with the equation that we had, we knew our x-intercept was 0 and our y-intercept was 0. So we can go ahead and put that on the graph. We know that there's a point at 0, 0 because that's what we found in our intercepts. We also know that there is a horizontal asymptote at 9 because we used the coefficients, because it's the same degree over the same degree, so 9 over 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so there's going to be a horizontal asymptote. It's a really straight line. So we have a horizontal asymptote at y equals 9. We also have a vertical asymptote at x equals 7. So 1, 2, 3, 4, 5, 6, 7. So I know that I have an asymptote here at 7. There's no removable discontinuities, so this is kind of the basis for where our graph is going to lie. So because there's a point here, and on my asymptotes, everything is going to get closer and closer and closer to that asymptote as we go this direction. As we go this direction, we're going to get closer and closer and closer to this asymptote, knowing that the basic shape of my rational function looks like this. So there's two asymptotes here on the original function, and so this one's going to get closer and closer, this one's going to get closer and closer. So I can't go any further down, like I can't go up and then down because there's no x-intercept over here in my equation. So we know that this is going to be here, and we know that this is going to be here. That would be a more smooth transition, but you guys know my drawing skills are bad. Okay, so if this is here, more than likely this other part is going to be here. So what we want to do is plug in a value that's on this side of my x. So if this is x equals 7, I'm going to plug in x equals 8 into my equation to figure out, is it going to be above this line or is it going to be below this horizontal line here? So if I have 9 times 8 over 8 minus 7, 9 times 8, 72, and 8 minus 7 is 1. So 72 is a very large number. It's bigger than 9, so we know that this point is going to be somewhere way up here. So these asymptotes kind of keep that graph within that. So you're not going to leave those asymptotes. So we can just assume that this graph is going to stay in this section of my graph. So everything is going to stay here, and everything is going to stay here. And that's the only place that your graph is going to intersect the y-axis and the x-axis. Okay? So that's kind of the first example. Here's the next example. This one's going to have a slant asymptote. So I'm not going to have you guys graph those, not while I'm not here. We may do that later, later next semester. So I'm going to skip this one. Alright, now we're going to look at number 3. So number 3 has an x-intercept at -4, has a y-intercept at 2, horizontal asymptote at 1, and a vertical asymptote at -2. So at -4, graph our x-intercept. At our y-intercept is 0, 2, so we'll graph that intercept. We have a horizontal asymptote, y equals 1, and at x equals -2, we have a vertical asymptote. Okay, so and then we have a removable discontinuity at x equals 3. And so let me talk about a little bit, we didn't talk about this on the last video, but I'm going to talk about it now. So when we factor this, or when you do quadratic formula, we end up with x plus 4 and x minus 3 and x minus 3 and x plus 2. So that's going to divide out. That's what's causing these other things. So if we plug in 3, now the problem at 3 is gone. We've divided it out. But if we plug in 3 into what's left of my equation, we can figure out where that point should be. So if I plug in 3 plus 4, that would be 7, and 3 plus 2 would be 5. So if we divide that, we end up with 1.4. So this is the y value at x equals 3. So at 1, 2, 3, we're going to have a point. So here's 1, so we're going to have a point just above that. It's going to be an open circle because it's a removable discontinuity. We have a point in this section of our graph. So our graph is kind of divided into 4 sections. And because it's a rational, there's only going to be 2 sections that have graph in it. Well, this one has 2 points. This one has a point. So the rational graph can get drawn through that point and then get closer and closer and closer to both of those asymptotes, just like every other rational function that we've seen. This one's going to start close to that asymptote. It's going to go through the point that we know, through the removable discontinuity, but it'll stay open, and it'll get closer and closer and closer to that asymptote. So that's kind of how that graph is built. We can use the information that we found to graph our rational function. Okay, so that's number 3. And then number 4, we have pretty straightforward. There's no removable discontinuities. It's y equals 0 and x equals 0. So on our axes, so there's an asymptote here, there's an asymptote here, which means that we don't have any x-intercepts and we don't have any y-intercepts anywhere. So what we need to figure out is when x is less than 0, what's happening? Is it a positive number, so is it going to be in this section, or is it going to be a negative number in this section? And then when x is positive, when x is greater than 0, is it going to be in this section, or is it going to be in this section? So that means we just need to plug in a value. So 3 is 3 divided by -1. So that would be in this section over here, where x is less than 0. So 3 divided by -1 would be -3. That's pretty obvious. So that means that my y value, or my h of x value, is going to be negative, which means that if the y value is negative, it has to be in this section down here. And then, if x is positive, so if I plug in +1, 3 divided by 1 is +3, and so all my y values up here are positive, and so that last section of my graph is going to be in this section here. And all our graphs are just sketches. They're not perfect. They're just sketches, like taking the information that we know, graphing it where it goes, and then drawing our shape around that. Okay? Hopefully that made sense to you, and you guys are able to work on your assignment.